Hi guys, I'm going to dive right into chapter 2 of The Quantum and the Lotus. This is definitely one of my favorite things to read. And I have my coffee today. My goal is not to dump it all over myself. To be and not to be. Does the universe have a beginning? The notion of the beginning of the world is fundamental to all religions and also to science. The Big Bang Theory, which states that the universe originated about 15 billion years ago, along with time and space, is the best scientific explanation for how the universe began. Buddhism's approach to the question is different. It argues that the idea of a primordial beginning is mistaken, and that our world is one of an endless series of worlds. Was the Big Bang truly a primordial explosion, or the start of one particular universe in an incalculable series of universes without beginning or end? Is the notion of the beginning of time and the universe perhaps fundamentally flawed? In our present state of knowledge, the Big Bang is the theory that best explains the origin of the universe. We think of the universe was created about 15 billion years ago when an unimaginably small, dense, and hot concentration of energy exploded, in the process also creating space and time. Since then, the universe has continued to expand. This theory was formulated by the American astronomer Edwin Hubble, observed in 1929 that the vast majority of galaxies were moving away from ours, the Milky Way, at high speed. Even stranger, the more distant the galaxies were, the faster they were moving. A galaxy 10 times the distance away moves 10 times more rapidly. Scientists deduced from this observation that all of the galaxies had taken exactly the same time to move from their starting point to their present position. Now, if we imagine a film of galaxies moving further apart in the universe, and we run it backward in our mind, we discover that all the galaxies retrace their paths, as all the galaxies retrace their paths, they'd meet up at the same point in space at the same moment. This insight led to the idea of a big explosion, or Big Bang, that kicked off expansion. For many, the Big Bang replaced the religious idea of creation. When it was first conjectured, the idea of the Big Bang met a great deal of resistance. However, some scientists immediately took the idea seriously. In 1922, the Russian meteorologist and mathematician Alexander Friedmann used Einstein's general relativity theory to construct a model of an expanding universe. The Belgian cosmologist priest Georges Lemaitre independently did the same thing in 1927 and dubbed the infinitesimally He dubbed the infinitesimally very small original state of the universe the primordial atom. The Russian-American physicist George Gamow worked in 1946 that during the first 300,000 years of the universe's existence, its temperatures and density were so great that none of its current structures, galaxies, stars, life, could have existed, and that it contained only elementary particles and radiation. According to Gamow, that hot primordial radiation should still be reaching us, though greatly cooled down by the energy lost during the 15 billion years of the universe's expansion. Matthew. That's what's called cosmic background radiation, right? Swan. Yes, it's what's left of the heat of the fire of creation, and its detection in 1965 offered our best proof yet for that theory. But no one bothered to look for the background radiation for many years, and it was discovered in 1965 only by accident. There were two reasons for this delay. First, the idea of the Big Bang was embraced by many theologians, which put some astrophysicists off. In 1951, Pope Pius XII likened God's words in the book of Genesis, "Let there be light," to the explosion of the Big Bang. The other reason scientists failed for so long to look for the background radiation is that a competing theory to that of the Big Bang was put forward that sidestepped the issue of creation. The steady-state theory was devised by three British astronomers, Hermann Bondi, Thomas Gold, and Fred Hoyle. This theory argued that the universe was in a steady state, meaning that it had always been and would always be pretty much the same as it is now. In other words, it has neither a beginning nor an end. But observations soon undermined this theory. In the early 1960s, quasars were discovered. These celestial objects at the edge of the universe that emit enormous amounts of energy from a very compact volume. Radio galaxies, which emit most of their energy as radio waves, were also discovered. Observations showed that the population of both quasars and radio galaxies was changing, that they became fewer in number with time, which contradicted the idea of an unchanging steady state. Then, in 1965, with the unexpected detection of the cosmic background radiation, the steady state received its final blow. The theory argued against the notion of a beginning and of a superdense and superheated explosion, and couldn't explain the presence of the remains of this primordial heat that still bathes the entire universe. So the Big Bang theory became the widely accepted explanation for the origin of the universe. The Big Bang was the only explanation that could account for such apparently unrelated phenomena as the outward motion of galaxies, the cosmic background radiation, and other important characteristics of the universe, such as the chemical makeup of stars. But how could such a massive explosion result in the evolution of the universe? What immediately followed the Big Bang? And how, according to the theory, did the universe take shape? Swan. Physicists say that the universe was born from a vacuum. They call it the quantum vacuum. But this vacuum was not calm and peaceful as you might imagine. The quantum vacuum was seething with energy, even though it contained no matter. What seems to be empty space is filled with energy fields that can be described as waves. In fact, the space that surrounds us is filled with a veritable kaleidoscope of waves of different kinds. Radio waves have the least energy. With the simple turn of a switch, modern electronics magically convert them into a Beethoven symphony or a TV show. Visible light rays from the sun constantly ricochet off the surface of the objects around us and then enter our eyes, allowing us to see. Solar ultraviolet rays are also present, just as the space around us is teeming with such waves. The quantum void that existed at the birth of the universe was bursting with fields of energy. In a remarkable process that is mind-boggling in its scale, this enormous energy drove the universe to expand extremely rapidly. Astrophysicists call this phase of the universe evolution the period of inflation. This inflation led to a staggering increase in the volume of the universe in practically no time at all. Between 10 to the negative 35 and 10 to the negative 32 seconds after the Big Bang, the universe grew exponentially from being smaller than a hydrogen atom to the size of an orange. As the universe expanded, it also grew much cooler. Right after the Big Bang, the universe was hotter than all of Dante's Infernos put together, and this incredible heat prevented the formation of matter. As the universe cooled, energy began to be converted into matter according to Einstein's famous formula, E equals mc squared. As Einstein discovered, the quantity of energy can be converted into a particle of matter, and its mass, m, will be equal to the quantity of energy, E, divided by the speed of light, c, squared. From this point on, the history of the universe is a long ascension toward complexity. Elementary particles, quarks and electrons, for instance, rose out of the primordial vacuum and came together to form atoms, then molecules, and finally the stars. Those stars assembled together to create galaxies, each containing several 100 billion stars, and the hundreds of billions of galaxies in the observable universe formed an immense tapestry covering the cosmos. The infinitely small had created the infinitely large. At least one of these galaxies, the Milky Way, near a star called the Sun, on the planet Earth, molecules locked together to form long chains of DNA. which created life, then consciousness, and finally, people capable of asking questions about the world around them and the universe that caused them to exist. Matthew. No matter how convincing this theory is about the evolution of the universe, it doesn't explain the cause of the Big Bang. When I mentioned the Big Bang to a learned Tibetan friend, he explained, so the universe, time, and space all began with a pop, ex nihilo, without a cause, nihilo, ex nihilo, without a cause. Because that's as illogical as postulating the existence of a creator who is his own cause. That's right. If God created the Big Bang, who created God? According to Buddhism, time and space are just concepts created by our perception of the world and have no existence apart from our perception. In other words, they are not real. The idea of an absolute beginning of time and space is therefore flawed according to Buddhist thinking. We also believe that nothing, not even the apparent start of time and space, can come without causes or conditions. In other words, nothing can start to exist or cease to exist. There can only be transformations. The Big Bang must then be a mere episode in a continuum without a beginning or end. Fun. You raise a troubling issue for the Big Bang theory. The truth is that we cannot say what happened before the Big Bang. I'm putting quotes around before because if time started with the Big Bang, then the idea of a before becomes meaningless. Does science allow us to go all the way back to the moment of creation? The answer is no. Right now, there is a wall in the way, which is called Planck's wall, named after Max Planck, a German physicist who first studied the problem. This wall stands at the infinitely small time of 10 to the negative 43 seconds, the number 1 preceded by 43 zeros. This is called Planck time. At that moment, the universe was 10 trillion times smaller than a hydrogen atom. Its diameter was equal to the Planck length, or 10 to the negative 33 centimeters. Matthew, are you saying that this is some kind of natural limit, that we can never know what happened before this? Or is this barrier caused by our lack of knowledge? Come on. Planck time isn't an absolute limit. Our inability to see what happened before this time is simply a product of our ignorance. At the moment, we don't know how to unify the 20th century's two great physical theories, quantum mechanics and relativity. The former describes the infinitely small and accounts for the behavior of atoms and light when gravity isn't dominant. The latter describes the infinitely large and allows us to understand the universe and its structures at a cosmic scale, where the two nuclear forces and the electromagnetic force are not predominant. And that's the snag. We don't know how to describe the behavior of matter and light when the four fundamental forces are on equal footing, which is the way things were at Planck time, or 10 to the negative 43 seconds after the Big Bang. Behind this artificial wall lies a reality that is still unknown to physicists. But some think that space and time, which are so intimately linked in the universe today, were separate in the early universe. According to this scenario, time no longer exists. The concepts of past, present, and future all lose meaning. Divorced from its partner, time-space becomes a quantum foam with constantly changing and shifting forms. Divorced from its partner, time, space becomes a quantum foam with constantly changing and shifting forms. Some physicists who are working on the theory of superstrings say that this quantum foam doesn't exist. According to the alternative theory, elementary particles are created by the vibration of teeny strings of energy that are a Planck length long. Because nothing can be smaller than these strings, the problem of what happens to space on scales smaller than Planck length disappears. Space simply can't have a smaller dimension. This theory seems to have the potential of unifying quantum physics and relativity, but right now it's wrapped in a thick mathematical veil and hasn't been proved experimentally. If we accept the existence of quantum foam, then possibly one of these innumerable shifting forms in the quantum foam created the universe and space-time about 15 billion years ago. Before then, it's impossible to say that space spent so long in this or that form, since time didn't exist. An infinite period may even lie behind Planck's wall. Matthew, when you say infinite period, do you mean without a beginning? Swan, anything is possible. We simply arrived at 10 to the negative 43 seconds by extrapolating the known laws of physics back towards zero time. But they break down behind this wall, so it is that our current physics begins at 10 to the negative 43 seconds after the Big Bang. Matthew, for Buddhism, the reality of our universe is seen from a quite different perspective. Buddhism considers that phenomena aren't really born in the sense that they pass from non-existence into existence. They exist only in terms of what we call relative truth and have no actual reality. Relative or conventional truth comes from our experience of the world, from the usual way in which we perceive it. That is, by supposing things didn't exist, objectively. Buddhism says that such perceptions are deceptive. Ultimately, phenomena have no intrinsic existence. This is the absolute truth. In these terms, the question of creation becomes a false problem. The idea of creation becomes necessary only if we believe in an objective world. The Buddhist view does not, however, exclude the possibility of the unfolding of the world. Obviously, the phenomena we'll see all around us aren't non-existent, but if we examine how they exist, then we soon see that they can't be viewed or set as a set of independent entities, each with its own existence. Thus, phenomena exist only as a dream, an illusion, or mirage. Like mirror images, they can clearly be seen, but have no separate existence. Nagahuna, the great 2nd century Indian philosopher, said, "The nature of phenomena is that of mutual dependence. The nature of phenomena is that of mutual dependence. In themselves, phenomena are nothing at all. Their evolution is neither random nor fixed by divine intervention. Instead, they follow the laws of cause and effect on a global interdependence and reciprocal causality. The problem of an origin comes about only from a belief that in the absolute reality of phenomena and the existence of space and time. In terms of absolute truth, there is no creation, no duration, and no end. This paradox is a good illusion of the illusory nature of the world of phenomena. This paradox is a good illustration of the illusory nature of the world of phenomena. It can reveal itself in an infinite number of ways because of its final reality as emptiness. In terms of the relative truth of appearances, we say that the conditioned world, called samsara, is without beginning, because each state must have been caused by the previous one. So, with the Big Bang theory, we do have an ex nihilo creation, a creation out of nothingness, or the expression of some kind of pre-existing potential that is not yet manifested in the universe. Is it seen as a real beginning, or as a stage in the universe's evolution? One, as we've discussed, modern physics can't look into the time before Planck's wall. So before the Big Bang, there could easily have been an infinite period of time, or else no time. Another possibility is that the universe is cyclical, and the Big Bang is just the start of one cycle among an infinite number of cycles. In either case, the issue of how the universe could possibly have arisen ex nihilo at zero time is avoided. Those possibilities are ways of dodging the creation problem, but they are still pure speculation, unsupported by observation or experiment. Matthew, perhaps the Big Bang can be interpreted as the process of the world of phenomena springing forth from an infinite but non-manifest potentiality, which is metaphorically called the particle of space in Buddhism. This term doesn't refer to particles in the sense of bits of matter, but rather to space's potential. This potential could perhaps be compared to the vacuum of physics you described, so long as we don't invest the potential with any form of concrete or independent reality. For Buddhism, we believe there can be ex nihilo creation. As Shantideva wrote in the 7th century, when nothing prevails, if there's no being, how could being ever supervene? For insofar as entity does not occur, non-identity itself will not depart. And if non-entity is not dispersed, no chance is there for entity to manifest. Being cannot change and turn into non-being, for otherwise it has a double nature. The reason why nothing can't become something is that in order to do so, the nothing would be done away with. But how is it possible to get rid of something that does not exist? Nothingness is a mere concept defined in relation to existence. It does not have the slightest reality on its own, because it cannot be conceived in the absence of existence. Nothingness cannot be transformed. If something appears, it means that the potential for manifestation was already present. One. Physics says that the potential for manifestation lies in the vacuum's energy, but we are still left with the question, how was the vacuum created? Was there nothing, then a sudden rupture, with the appearance of a vacuum full of energy simultaneously of time and space? I'm British. Matthew, a causeless rupture, making nothing become something? That is quite a way to start. The Big Bang, or any other beginning of a given universe, can't happen without a cause and conditions. The world of phenomena can't have come from nowhere. One of Buddhism's essential ideas states that because things have no independent reality, they can't really begin or end as distinct entities. When we speak of a beginning, our mind immediately pictures something. The idea of the universe beginning and ending belongs to relative truth. In terms of absolute truth, it's meaningless. When you consider a castle seen in a dream, for instance, you don't need to worry about who actually built it. All religions and philosophies have come unstuck on the problem of creation. Science has gotten rid of it by removing God the Creator, who has become unnecessary. Buddhism has done so by eliminating the very idea of a beginning. Swan. Do you remember the story of the great 18th century French mathematician and scientist Pierre-Simon de Laplace? When he gave Napoleon a copy of his great book on celestial mechanics, the emperor scolded him for not once mentioning the great architect. Laplace replied, "But your highness, I have no need of that hypothesis." Questions still remain, however. Why was there a universe? Why are there laws? Why was there a Big Bang? We return to Leibniz's famous question. Why is there something rather than nothing? For nothing is both simpler and easier than something. Moreover, assuming that things must exist, there must be a reason why they exist thus and not otherwise. Matthew. One reply would be the famous dictum of the 2nd century master Nagarjuna. Since all is empty, all is possible. And the famous scripture Perfection of Wisdom says specifically, though phenomena appear, they are empty. Though empty, they appear. In Buddhism, emptiness isn't just the true nature of phenomena. It's also the potential that allows the propagation of an infinite variety of phenomena. To use a simple metaphor, the continents, trees, and forests can exist because space allows them to. If the sky were made of rock, nothing much would happen. In the same way, if reality were permanent, and its properties too, then nothing would change. Phenomena could not appear. But because things have no intrinsic reality, they can have infinite manifestations. When you have understood that everything is intrinsically empty, it's easier to understand how things work in relative or conventional truth. Even though phenomena lack reality, they don't happen at random. This is the emptiness of Buddhism. This isn't nothingness, but rather the absence of any permanent or autonomously existing phenomena. Swan. Yes, but many people associate emptiness with nothingness. In the 19th century, Buddhism was accused of being nihilistic. Matthew. That was a serious mistake. We consider that there are two opposing and erroneous points of view, nihilism and materialistic realism. The latter, which Buddhism calls eternalism, reifies the world by postulating the existence of immutable matter made of solid parts. What is more, when Leibniz wondered why there was something rather than nothing, he presupposed that there really is something. In Buddhism's middle way, there is neither nothing, nihilism, nor something, materialism or realism. We could now ask Leibniz, why should there be nothing, since phenomena are possible? The true nature of interdependent phenomena goes against common sense because these phenomena can't be called either existent or non-existent. The intellect has limitations, and we can't grasp the true nature of reality just by means of ordinary conceptual processes. The only direct knowledge that transcends conventional thought can see the world of phenomena in a non-dual way, in which subject and object have become meaningless. Swan. What, then, is the Buddhist explanation of how our world came about? Does Buddhism have a cosmology? Yes, it does. I'm sorry, Matthew. Yes, it does. But in a non-dogmatic way. While some parts of the description have now become outdated, they continue to have a symbolic meaning in meditation. These parts of the cosmology conformed to the ideas of the time, which Buddhism adopted, but which were not taught by the Buddha himself as absolute truths. This cosmology in no way contradicts Buddhism's analysis of reality. It is important to bear in mind that the idea of the universe coming together belongs to relative truth and the world of appearances. So, in relative terms, Buddhism talks of the formation of our universe out of particles of space that don't stand for bits of matter, as I've said, but rather for the potentials. Out of these particles of space, a void formed that was full of 5 winds or energies, prana in Sanskrit. These energies appeared as lights of 5 different colors that gradually materialized into 5 elements: air, water, earth, fire, and space. When combined, they formed a soup, an ocean of elements that was whipped up by the primordial energy, thus producing the heavenly bodies, continents, mountains, and finally, living beings. This is the formation of the universe among the infinite numbers that exist. There is no idea of initial creation, because no one prime cause can be accepted. One, despite the imagistic language, this description of the world's beginnings resonates well with modern scientific ideas. From both perspectives, we are a million miles from seeing the birth of the universe as the result of the gods' loves and rivalries. I'm particularly intrigued by the notion of the full void we find in both science and Buddhism. Matthew. Yes, but be careful. There's a fundamental difference. Science talks of the universe as a truly existing independent object. Buddhism, as we shall see, considers the universe is not independent from consciousness. We could say that the subject and object mold each other. The object does not exist without the subject, and vice versa. Buddhism envisages I don't know if I've ever said that word out loud. Envisages? A cyclical universe, though neither cyclical. Let me start the sentence over. Buddhism envisages a cyclical universe, though neither circular nor repetitive, as it was for the Stoics. Each cycle is made up of 4 periods: formation, continuity, destruction, and the non-manifest state, which is the intermediate void between 2 universes. Particles of space ensure that there is continuity between one universe and the next. This cycle has neither an end nor a beginning. Swan. Modern cosmology also contains the idea of a cyclical universe. If there is enough matter in our universe, then the force of gravity will, at a certain time, stop the universal expansion and pull the galaxies the other way. We will then have a big crunch, as the opposite of the Big Bang. The stars will evaporate in the intense heat, and matter will fall apart into elementary particles. The universe will end its life in a blinding implosion into an extremely small, hot, dense state. Time and space will once more become meaningless. Can a universe that has collapsed into itself be reborn phoenix-like from the ashes? This sentence. Can a universe that has collapsed into itself be reborn phoenix-like from its ashes with, perhaps, different physical laws? No one knows. For, as we were just saying, modern physics loses its grip on Planck time and can't deal with such extreme temperatures and densities. Matthew. According to the Buddhist view, the end of a cycle is marked by a final conflagration. It is said that 7 increasingly intense fires will burn up the visible world. The universe is then absorbed once more into the void, and a new cycle can begin. This one. According to modern cosmology, if the universe did start other cycles, then they would all be different. The universe would build up more and more energy so that each new cycle could last longer than the previous one, and the universe's maximum size would get bigger and bigger. It's rather like the idea of non-repetitive cycles you just mentioned. But our universe doesn't contain enough matter for gravity to stop its expansion. It will continue spreading until the end of time, and so won't be cyclical. In the end, the stars will burn up all their nuclear fuel and go out. They will no longer light up the heavens. The world will be plunged into a long, dark night. Heat will fade away, and the temperature will get closer and closer to absolute zero, but without ever reaching it. With no more energy to keep it going, life as we know it will disappear. In the far distant future, the universe will be an immense sea of radiation and elementary particles. According to our present state of knowledge, the universe's expansion is to be reversed. If the universe's expansion is to be reversed, then the universe must contain much more matter than has so far been observed. That said, finding out how much matter the universe contains is not an easy job given the large amount of dark matter, at least 90% of the total, that doesn't send out any radiation and just has a gravitational effect on its surroundings. Without light, astronomers are quite literally in the dark. Recent observations of supernovas, exploding stars, in distant galaxies seem to show that the expansion of the universe, rather than slowing down, which would be the case if gravity were the only factor in question, is actually accelerating. This accelerating expansion implies the existence of a mysterious dark energy, also called quintessence. If this turns out to be right, then the universe will expand forever. There could be no new Big Bang to start a new cycle without there first being a big crunch, which would be impossible if the universe truly were expanding more rapidly all the time. But the properties of distant supernovas have not been properly understood yet, and this conclusion requires further verification. I should also mention that a recent preliminary observation of the temperature fluctuations of the cosmic background radiation also appear to indicate the presence of that dark energy. Matthew. We aren't just talking about matter when we depict the universe as a series of metamorphoses without a beginning. Consciousness has no start. In Buddhism, the matter/consciousness duality, the so-called mind-body problem, is a false problem, given that neither of them has an intrinsic, independent existence. The problem of the lack of any first cause for phenomena and consciousness falls into the category of what Buddhism calls the inconceivable. But we need to not stand in dumb incomprehension in front of such mysteries unsolvable by the intellect. Certain things simply cannot be grasped using ordinary concepts. The idea of a beginning is inconceivable, not because it would be so long ago or so far off in space, but because our discursive minds cannot stand back from that process of beginning in a way that is needed to transcend all concepts. Our ordinary way of thinking emerged from that same process and thus can't place itself outside the chain of causes and so determine its own origin. Swan. That argument sounds remarkably like the scientific argument about insolvability known as Gödel's incompleteness theorem. This theorem, devised by the famous mathematician Kurt Gödel, implies that we are always limited in our knowledge of any system, such as that system we call the universe. while we ourselves are part of that system. In any case, modern science has nothing to say about the possible coexistence of consciousness and matter since the beginning of time. Matthew. The notion of inconceivability helps to drive away the reifying instincts that make us see phenomenon as autonomous real entities. Since the ultimate nature of phenomena lies beyond the intellectual concepts of existence and non-existence, it can be called inconceivable. Without this being synonymous... Oh, I got too excited. God, this guy makes long sentences. Since the ultimate nature of phenomenon lies beyond the intellectual concepts of existence and non-existence, it can be called inconceivable without being synonymous with ignorance.